Welcome to this Triangle Apache Spark Meetup. Our meetup has been running since 2015, roughly before myself as a host. Jan Pointer started this meetup, and nowadays what happens is that we decided to go virtual. The last in person was actually the last was actually in person was in January. It was a great meetup with LexisNexis, but since it was a bit difficult to do anything, so I said, hey, let's go virtual. And the benefit of going virtual is that we've got plenty of visitors from all over the world. So Jean-Yves is from France, okay, not related to me, okay, because we Jean-Yves, Jean-Georges, not related. But the thing is, it allows to have guests from all over the place, and as well as visitors from all over the place. I see a lot of people who joined actually from India, and this is just great. I love this format. It's fantastic. So just before we get started, and because we are a lot of new people there, I just wanted to quickly introduce North Carolina. Okay, so I did my own slides, so you can see my slides, okay, here. So this is North Carolina, okay? So here I'm zooming on North Carolina, so you can do these things very interactively. The main cities are Raleigh. I'm actually in Chapel Hill, which is one of the triangles there. And we are not very far from New York and Washington. We are on the East Coast, okay? Compared to France, I know we've got a few French people there. So we have about 4,000 miles away, and we have 6 hours East Coast. That's just great. We are also, when you look at the US, it's kind of fantastic because we are very close to, you see the flight time radius there. 1 hour, you're almost any big cities on the East Coast. 3 hours, you go to even Texas, and even the West Coast is pretty close. Well, of course, those days it's not as fun to fly all over the place. We have a lot of high technology there. IT. Here's a bit of the companies you can find. We've got Apple, we've got Cisco, we've got IBM, which is a big campus here. We've got even Google in Chapel Hill. We've got a bunch of data centers. So this is also something which is pretty impressive. So basically, the Triangle region, North Carolina, it's really good for technology. And recently, I'm going to do a little cocorico, so a little bit proud of France. We have started La French Tech. So La French Tech is this hub of technology sponsored by the French government. When it means sponsored by the French government, it means that they give us absolutely $0. So, but the thing is, or euros, it's great for promoting technologies both ways. NC Tech in France and French technology also in the US. Okay, and that's a bit in this context that we are having Jean-Yves today. So, and the last thing is, if you didn't get it yet, just buy this book. It's an amazing book on Spark. And you can see that I've got the same T-shirt. I've wrote this book, 3 years efforts. Well, anyway, that is the 2 minutes of self-promo I need to do. That's how I justify paying for Zoom and Meetup. Okay, so I'm shutting up now. You didn't come to hear me, but you're going to hear Jean-Yves, and I will send a lot of links. We're recording this event, so expect some follow-up. So, Jean-Yves, the floor is yours.
Thanks a lot, Jean-Georges. You will need to allow me to share my screen as Zoom doesn't allow me yet. So welcome, everyone. We're going to get started. In my slides, I'll start with a quick personal introduction, and then we'll go over the topic, making Spark on Kubernetes stable and performant at scale. In this talk, I will reuse some of the content we previously gave at a session in Spark Summit. I'll also use some of the content we previously published in blog post. But I think most of you are probably still fairly new to Spark and Kubernetes. So I'll try to start with an introduction, like core concepts, and then gradually give also more advanced advice to get the best performance, best stability about Kubernetes. Great, I can share my screen. So I'm going to start the deck. Jean-Georges, should we take some questions as we go, or everything at the end? You're muted. Sorry. I cannot hear you. Let's see. Zoom. Well, I couldn't hear you, but let's see. I'm a little bit lost with Zoom myself. We're going to get started in a couple minutes. I presume we're going to take questions at the end. But Jean-Georges, if you feel like stopping me at some point to make this more interactive, like speak orally one of the questions on the chat, feel free to do so. Great. So let's get started. Maybe just before I dive into the topic of Spark on Kubernetes, I'll start with a quick introduction. So first, I'm really pleased to meet you all. I'm JY. I'm co-founder of called Data Mechanics, and we are a serverless Spark platform deployed on Kubernetes, which is why I am giving talks about making Spark on Kubernetes stable and performant. Previously, I worked at Databricks as a software engineer. I led their Spark infrastructure team. So kind of my role was to automate the launch, configuration, and maintenance and monitoring of Spark clusters in the cloud. This is kind of our agenda. I'll start with a quick primer on what is data mechanics, so you understand where I'm coming from, what is my experience with it, why, how come I know stuff about Spark and Kubernetes, and then we'll get into really the meat of the topic at hand. So Spark and Kubernetes, its core concepts, how it differs from running Spark on other schedulers like Yarn. And then we'll go into like more advanced stuff about really production advice for running Spark on Kubernetes, performant and stable at scale. And finally, in the conclusion, I'll talk about some of the future works for Spark on Kubernetes and some advice on whether it's worth getting started. Great. So let's go. At Databricks is an amazing end-to-end data science platform. It's great if you want to use their hosted notebooks, their hosted scheduler, but I felt like Databricks didn't make Spark performant enough, easy enough, and so we set out to build a serverless Spark platform. Now, what does it mean, serverless? There are always servers running, so what does it mean to us? First, it means that our platform tunes the infrastructure parameters and Spark configurations automatically for each pipeline, so that you don't need to, you should just submit your application code and then the platform automates the deployment, the configuration, the maintenance as much as possible. Second, we are fully containerized, and in fact, each Spark app has a Docker image, and it's deployed on a Kubernetes clusters inside our customer's cloud account. And this is pretty new. Actually, none of the major commercial platforms for Spark run on Kubernetes, okay? They all run on Yarn, or for Databricks, they run on a custom cluster manager. And last, we also have a slightly different pricing model. We don't charge our customers based on server uptime, because the server uptime is often wasted. And instead, we only charge them when they do real work, when they really run Spark tasks. So just to illustrate these 3 points, first, the automated tuning. We gave a talk about this, so I won't go into the detail, but basically, We automate the tuning of some infrastructure parameters, like the type of instance you should use, how much memory and CPU, how many executors. We tune the Spark configurations, like number of partitions, shuffle, memory tuning. The way we do it, it's automated. It's happened by analyzing the logs produced by a Spark application, the Spark event logs in particular, and figuring out if there's a performance issue or a stability issue, and then apply parameters, infrastructure parameters, Spark on the next run of the app. And so there's an entire tech talk about it, but basically it means our customers don't need to do this manually, so it's easy to use, and then you get a significant stability and performance boost. Stability is you can avoid issues or automatically remediate them, let's say on a memory issues, and performance, well, by tuning the infrastructure right, we were able on average to get a 2x performance boost, so to reduce our customers' cost by half. And I think we can go further into that. Now the second point about our architecture, and this is good because it introduces the topic of deploying Spark on Kubernetes. This is our architecture for the data mechanics platform. So we are deployed on a Kubernetes cluster inside our customer's cloud account. It's important that it's inside their cloud account. It's for security and data privacy reasons. The Kubernetes cluster can be almost cut off from the internet. There's no need to be any inbound connection. It could be behind the company VPN, in their VPC, and so on. The Kubernetes cluster, we manage it for our customers. So when our customer signs up, they give us some credentials that let us, deploy new releases every 2 weeks, provide support if we need to. So they don't need to manage the Kubernetes cluster themselves. It's part of the service we provide. And at a high level, I won't go into the detail again, but you can use our platform by either connecting notebooks like Jupyter Notebooks, or by submitting apps programmatically through a script, through a scheduler like Airflow or any other. And then you're going to hit our endpoint. We call this the Data Mechanics Gateway. It's the entry point for launching Spark applications. And this gateway is going to launch Spark apps, configure them, scale them, and give you access to a monitoring UI. Lastly, and then we're going to move on to really the topic of Spark and Kubernetes. We call the platform serverless also because we have a different pricing model. We only charge our customers when they are running Spark jobs, and we charge them by the total duration of all the Spark tasks that they ran. The Spark task is the smallest unit of work that Spark will schedule on an executor. And typically, at Databricks, we saw that on average, our customers' infrastructure could be unused, not quite 80% of the time, but 2/3 of the time. So that was huge. And unfortunately, we could have made it better, but if we did, at Databricks, we would have lost some revenue because we were charging them based on how many servers they're running. So if we cut down the waste, we would be losing revenue. So that's why I think that's not a great pricing scheme, and that's why we chose a pricing scheme that aligns our interests. We only make money when a Spark job is running. So that's the third point. That's why we call this serverless. Now let's dive into the topic of Spark on Kubernetes. And really, I'm talking from my experience working with Spark on Kubernetes over the last few years with many customers using us in production. So first, where does Kubernetes fit within Spark? Well, it's a cluster manager, also called scheduler for Spark. And previously, you had standalone, which is built in with Spark. You have Apache Mesos, which is open source and had a lot of traction early on. Oh, sorry. And then but lately less usage. And then you have Hadoop Yarn, and Yarn is really the dominant player. Amazon EMR, Google Dataproc, Azure HD Insight, and also Cloudera and Hortonworks, they run on Yarn. Kubernetes is the new player here, It's available since version 2.3. So maybe first, what is the architecture of running Spark on Kubernetes? What does it look like? So you have a Kubernetes cluster. In particular, in the cluster, there's a Kubernetes master. If you're using a managed cloud provider offering, you don't actually see the master. You just see the worker node. But when, as a user, you want to start a Spark application, you actually talk to Kubernetes, which is why we talk of a native integration. So you talk to the API server, and then Kubernetes is going to schedule the driver pod, and then the driver, the Spark driver, is going to dynamically at runtime, based on its needs, request executor pods from Kubernetes, and and getting them and launching them once the pod is started. A pod is basically a container. It can actually be more containers, but that's the Kubernetes abstraction for a set of co-located containers. Now, how do you submit Spark applications on Kubernetes? There are two main ways. Spark Submit, which is really the vanilla way from the open source repo. And it definitely works. Some things are a bit manual. Yeah, there is little customization support. And then there's also another open source project, not part of Spark itself, but like a different project by Google called the Spark on Kubernetes operator. And yeah, it has a lot of adoption. It doesn't only work on GCP, it works on any Kubernetes platform. And this is what we use. Typically, you'll see in the next slide, it's a bit easier to manage Spark application using the Kubernetes operator. You have some tooling to read logs, kill application, restart them, etc. It does require a long-running system pod on your Kubernetes cluster. So you just have a small overhead running on the cluster at all time. This is what the app management looks like in practice under the two setups. So if you use Spark Submit, you're going to be able, to use a traditional Spark Submit, just provide a Kubernetes URL, and then you can list pods, read logs, but it's pretty manual. There is no way to actually describe an app. There's no way to kill an app, restart an app. It's a bit harder to specify config maps, volumes, and so on. The Spark on Kubernetes operator adds a bit of sugar on top, and also basically manages Spark application as a native Kubernetes object. So if you're familiar with the kubectl, you can see here, you can say kubectl gets Spark application, and Spark application is a native Kubernetes object that you can list. You can see its log, you can describe it, restart it, kill it, and so on. Now, to compare more Kubernetes with Yarn. One of the main differences is around dependency management. On Yarn, you typically have a global Spark version and just generally global dependencies, meaning if you have multiple apps that you want to run at the same time, they need to share the dependencies, or they need to have different clusters. So that's why, let's say if you're using Amazon EMR, a lot of people choose to have ephemeral Yarn clusters that they just spin up, run the job, terminate it. But when you do this, you kind of miss out on sharing an infrastructure between multiple apps. The other issue is the lack of reproducibility. You typically tend to use init scripts, like small scripts that run at the container at runtime, and this is not as stable as using a Docker image. So on the Kubernetes side, you have full isolation, meaning each Spark application can have its own Docker image, its own Spark version, Python version dependencies. And again, the fact that it's containerized with Docker means you have full control over your environment. And so with that respect, Kubernetes is a clear winner, and also that's part of why, not just for big data, but in general in software development, people adopt Kubernetes and containerized infrastructure. So yeah, Spark on Kubernetes kind of gives you best of both worlds, meaning it gives you isolation between concurrent apps, and it gives you the cost efficiency of having a shared infrastructure. Because on the same Kubernetes cluster, you're going to be able to launch multiple apps with different Spark version, and you're going to be able to share the resources efficiently, like dynamically allocate more resource to an app or kill an app and allocate this capacity to another app. Another advantage of Kubernetes is the ecosystem. Well, first, Kubernetes is a good abstraction for the cloud provider. That's how, in our case, we really benefited from it because we were able to very quickly port our platform from GCP originally to Amazon and Azure. So right now we're available on these 3 public clouds. But in general, for our customers, use a lot of tools that plug in easily with Kubernetes. So, for example, for CI/CD, logging and monitoring, security, there are just lots of tools. Yeah, this is not really a difference, but more I just want to state it because some people expect differently. There is no inherent performance difference between running on Kubernetes and running on Yarn. Okay, so we published a blog post recently. You have the link. I think I'll make the slides public afterwards, or you can find it on our website. And we run the TPCDS benchmark on Kubernetes and Yarn using the same hardware, and really there were no significant performance differences. I think if you look and sum all of these queries, you'll see that Yarn had a couple percentage point advantage, but it was not statistically significant. And in difference, there's a lot more performance gain you can make by writing better code, tuning your infrastructure. So now that we talked really about at a high level what is Spark on Kubernetes, let's talk about productionizing Spark on Kubernetes, giving you performance and stability tips, and also talk about monitoring because that's obviously very central when you want to run something in production. So first, this is a common gotcha when you start to run Spark on Kubernetes. Let's say you have Kubernetes nodes. So nodes is really the underlying hardware, the instances. And these nodes have 4 CPU each. So naturally, if you want to run one Spark pod, one container, one executor per node, you're going to submit an app with this config, Spark executor scores equals 4. But actually, this app is never going to start. It's going to be stuck in pending state. Why? The graph on the right explains why. So maybe the node capacity is indeed 4 CPUs, but then Kubernetes is going to reserve some overhead for itself. So maybe you're going to lose a few percentage points. And then maybe you run some daemon sets for logging, monitoring, security. These are services that we typically run on every node, and these can also take some of your capacity. So in the end, maybe you only have 85 or 90% of your entire capacity available. And so you should take this into account. What you should submit is this configuration where you pass the cores request, and this should be smaller than the real capacity that's available, so that Kubernetes is able to place a container. Note that you can still specify cores equals 4. That's okay. That will just be read by Spark and tell Spark to run 4 tasks concurrently in your container. But the CPU request should not be 4. It should be 3.4 or maybe a bit more. This gotcha, this logic is typically automatically handled in our platform because otherwise it can be a bit manual. But it's not that hard either. Now, dynamic allocation. Dynamic allocation is a feature in Spark open source where Spark can dynamically scale up and down based on load. Okay, so if you have a part of your app that's highly parallelizable, Spark is going to notice that there are lots of tasks that it could run, and so it's going to request more executors, and then And then, after the app is run, so typically if you're running notebooks, it's very common, Spark is going to unplace them again. And so that's very useful, and it's now available on Kubernetes since Spark 3.0. It was not available on earlier versions. It works through a mechanism called shuffle tracking. So just to explain a bit more about shuffle, because the topic is going to come up also later when we talk about performance. Shuffles are the stages in Spark, well, not the stages, but the phases in Spark, where the data has to be communicated across the entire cluster. So typically there's always a write side and a read side. On the write side, each mapper is going to produce some piece of data, and then on the read side, each reducer is going to pull in the data from the executor. And so typically it's a very I/O intensive phase. On Kubernetes, dynamic allocation works by tracking which shuffle files are active. So let's say the Kubernetes cluster would like to scale down. Well, the driver is going to say, oh, I know that this executor, that executor hold shuffle files which are active, meaning they are going to be used downstreamed, and so I cannot remove them. If I remove the executor, I would lose the shuffle files, and then that would impact me. I would have to reschedule the entire stage. So for this reason, we track shuffle files, and so it's a bit of a limitation. Versus on Spark, if you enable, on Yarn, if you enable the external shuffle service, you don't have this limitation. So later in future works, I'll talk about some exciting projects for making dynamic allocation even more powerful. But this being said, it works really well, and it also plays well with Kubernetes autoscaling. So far, when we talk about dynamic allocation, we talked about each app being able to scale up and down, but the Kubernetes cluster can also scale up and down, meaning add nodes. Typically, if the Kubernetes cluster has capacity when an app requests containers, it typically takes about 10 seconds to start a container, so it's really fast. If you need to get a new node from the cloud provider, it typically takes 1 or 2 minutes, depending on the instance type, whether it's Spot or not, the cloud provider, and so on. And yeah, the Kubernetes autoscaler on GCP ships without having to do anything. But if you are on AWS or Azure, you need to install a Kubernetes autoscaler. That's an open source project. Yeah. And here at the bottom, I gave the configuration to enable dynamic allocation on Kubernetes with Spark 3.0. One last tip about dynamic allocation. Let's say you have a few data scientists working interactively with Spark. If they start a notebook, they might not want to wait the 2 minutes necessary to add a new node. So one trick is to provision what we call low priority pause pods. So this is a trick to always have a bit of spare capacity on your Kubernetes cluster. What happens is the pause pods forces the Kubernetes cluster to scale up, but when you submit an app, the Spark pod is going to preempt the pause pod. So the pause pod is going to be destroyed. It's going to be replaced with the Spark application, and then the Kubernetes cluster will auto scale again. So yeah, this is another configuration we have internally at Data Mechanics, and that mostly our customers who use Spark, interactively with notebooks, like to use. So I said I was going to talk about shuffle. So this is it, shuffle performance. It's very important because shuffle are typically the most I/O intensive and the slowest part of your Spark apps. When we ran the TP-CDS benchmark that I mentioned earlier, shuffle performance was the most impactful, and we had to make sure we configure disks in the right way to get a good performance. Why disk? Because on the mapper side, we write to the disk first, and typically this can become the bottleneck. So we have 2 tips. first, use local SSDs whenever it's possible. On GCP, it's just a toggle. On AWS, you have to use a specific instance type. These are really local to your instances. They have a great bandwidth. Note that it's not sufficient to just configure them on the cloud provider. If you do, the volume, like the disk, will be mounted on your instance, but Spark may not be able to use it just out of the box. You will need to specify a host path, and this is the configuration that we put here on the right. And again, it's on our blog post, and you can find it also there. And you can get up to 10x performance gains for IO-bound workloads. Now, the second tip is if for some reason local disks are not available to you, you can still use like standard disks, but then you should use bigger disks, because as documented from the cloud provider, bigger disks tend to give you much better latency and throughput. In our performance benchmark blog post, we compared the performance of all the TP-CDS queries by, I think, multiplying the disk size by, I forgot if it was 3 or 5. And well, for some queries that are not shuffle bound, it doesn't matter. But for queries where shuffle happen, and as you can see on this scale, like shuffle read, once it gets in the 10 to the power 4, you typically have a ratio of up to 5x. So up to 5x performance gain by just using bigger disks. And indeed, bigger disks will cost you a bit more, but the 5x gain on your performance, on your compute time, will save you much more money than the cost. So it's worth it. Another performance tip, and this is because when you use Spark on Kubernetes, you typically read data from an object storage, and by default, Spark was more written with HDFS in mind, and the default connectors do not perform very well with object storage. And so for this reason, we recommend that you use optimized committers like the S3A committer. And if it's not the case, like if there is no optimized committer, you should put this configuration, which uses the Hadoop committer version 2, and it's also it performs much better. So you could expect a performance boost of about 2x. Again, yeah, performance often ties with cost savings. So if you're cost conscious and want to reduce your cost, it's completely feasible to use spot nodes in your Kubernetes cluster. You just configure your node pool to have some spot nodes. You can reduce your cost by up to 75%. What we recommend and what we apply, what we make easy in the data mechanics platform is that you put only the Spark executors on Spot, but you put the driver on an on-demand node. The reason we do this is because obviously if the node hosting the driver is killed, your entire Spark app fails. While if an executor is killed, it's going to be replaced. You're going to acquire a new node, maybe on-demand, and then Spark can recover. So in our opinion, putting the executors on Spot and then driver on demand is the right trade-off. And on the Kubernetes side, you can do this using node selectors and affinities. Now we're moving into the topic of monitoring. So what tools do you have to monitor first pod resource usage? So this is a very generic question, not specific to Spark, but there are multiple tools. Sometimes the cloud provider has an integrated monitoring tool, or the Kubernetes dashboard is also pretty interesting. So you're going to be able to monitor your CPU usage, memory usage, disk usage. However, as I mentioned, it's not integrated with Spark at all. So what you're going to have to do is you're going to have to jump between maybe the Spark UI and this tool and try to reconcile the timestamps. And it's not that great. So if you want to have knowledge of the Spark side, obviously there is the Spark UI and the Spark history server. Spark UI is for live apps. Spark History Server is once an app is terminated, you can replay the Spark UI. So how you do this on Kubernetes? For the live Spark UI, you can port forward, meaning create a link from a port on your laptop to the same port, in this case, on the driver instance. So you can do this by just running this kubectl command, and then the Spark UI becomes available at this URL. For the Spark History Server, what you need to do is you need to store the Spark event logs through in an object store using this config Spark event log directory dir, and then you can install the Spark History Server by using a Helm chart on your cluster. Won't go into details, but there are some links. Yeah, and then obviously the only thing is with the Spark UI, you don't have the system metrics that I mentioned earlier. So you're probably going to have to jump between the two, and it's not super user-friendly. Sorry, I'm again doing a little bit of self-promotion, but at Data Mechanics, we want to solve this pain point, and so we're building a free and cross-platform Spark UI replacement. So it will have system metrics, like CPU usage, memory usage. Hopefully, like we're really trying hard to make a better UX than the current Spark UI. So give you a high-level overview of where your app spent most of its time, where there are some high-level performance issues that we can give, etc. So this is work in progress. There's a blog post. We'd love your feedback. Right now, our idea is that basically it will work by having an agent that will be open source, and the agent will run inside your Spark app. You can run it on any Spark platform, and this agent will stream metrics to our backend system that then will give you access to this monitoring UI through a URL. Let's see, how are we doing on timing? Yeah, pretty good. So I wanted to kind of get to the conclusion. In the conclusion, I wanted to talk about the future works that are planned for Spark on Kubernetes, and also give a bit of a recap of what we went through and give you some opinion on whether it's interesting, it's worth it to get started with Spark on Kubernetes. First, features being worked on. There are two very big features that are being worked on. I think these two features are probably the last blocker until the open source community is really ready to say, oh, Spark on Kubernetes is officially production ready. Today, if you look at the documentation, it'll say something like, oh, it's still experimental. Personally, I think it's far beyond experimental. Many very large companies are running on Spark on Kubernetes. But it's true, these two features are pretty exciting. So first, a shuffle improvement. So what we'd like to do is we'd like to fully disaggregate storage and compute. Earlier, when I talked about shuffle, you realized that Spark would write files to the local disks. And what this means is that if you suddenly lose the node, maybe because it was spot killed, or maybe because you use dynamic allocation, but you forgot to enable the shuffle tracking, you're going to lose the shuffle files, and then you're going to have to recompute the entire stage. So instead, what is being worked on is to use remote storage, like maybe an object store, maybe another remote storage, to persist shuffle files. And this could preserve performance as long as it's maybe done asynchronously. So Spark doesn't directly write to S3, which could be slow, but first writes locally, and then in the few minutes afterwards, asynchronously, it's copied to S3. And the goal of this is to enable full dynamic allocation. Okay, so you don't even need to track which shuffle files are active, because they're going to be persisted, and so it's always safe to remove it. And beyond just dynamic allocation, it would make Spark resilient to node loss. And this would be very strong, and this would go beyond what's possible today with Yarn. A second interesting feature is a better handling for node shutdown. It's related. If you lose a node, right now we start a process called graceful decommissioning. What this means is that the Spark driver. So if you get notified that the node is going to disappear in about a minute or two, which happens if it goes down because of spot kill or because it goes down because of maintenance, then the driver is going to blacklist the node. It's not going to send any new tasks to the executors scheduled on this node. And then another improvement would be that to use the little bit of time we have between when we know that the node is going to disappear and the time where it's actually gone, to potentially copy any kind of data that was not persisted on S3. And again, this is being worked on right now by Holden Corral. And then there are other usability improvements. I picked just one, local Python dependency upload, which is really nice. But many other features that you can follow mostly through the Spark developer list. So a bit of a recap about first the pros and cons of Spark on Kubernetes. And again, we have a blog post about this. And note that we are somewhat biased because we did choose Kubernetes for our platform. But really the biggest pros is the native containerization, the fact that it's a single cloud agnostic infrastructure for your entire tech stack. So meaning you're going to use Kubernetes. Maybe you already use it for your company's main product, but now you're going to be able to use it for your big data application. And it has a rich ecosystem. And finally, the efficient resource sharing that guarantees both resource isolation and cost efficiency. On the negative side, if you're completely new to Kubernetes, it can be the number of abstractions involved can be a bit scary at first. So there's definitely a learning curve. And also, since most managed platforms do not run on Kubernetes, you basically need to run this yourself in open source, and that's a lot of setup to do. So that's the reason why we build data mechanics, to make Spark easy to use and performant, and in particular Spark on Kubernetes. If you do want to get started with Spark on Kubernetes in open source, here's a bit of a checklist. So obviously, you create the Kubernetes cluster. You set up the Spark operator if you choose to use it. You create a Docker registry, which will store the Docker images that your Spark apps will use. You host the Spark history server to be able to replay the Spark UI for terminated apps. You potentially set up some monitoring for Spark application logs and metrics. And then, unfortunately, there is a bit more work to do. You need to configure your apps so that they're successful, meaning configure your node pools, your pod sizes, just like we explained earlier, so that the bin packing works well. You need to make sure I/O is efficient by attaching the right disks and putting the right libraries like S3 connectors in your image. And then, optionally, you could also enable dynamic allocation for Spark and Kubernetes autoscaling. I would really recommend it. And optionally, you could also enable spot instances and then configure your apps accordingly. And again, our platform helps with this. And obviously, also, if you just have some question, we're happy to help too. Because this is actually the end of the presentation. Hopefully, I did right on timing. I wanted to save some time, maybe about 10, 15 minutes to answer all your questions. So now is the time. Thank you all very much. So I can see lots of messages on the chat. Oh, I will have to unmute Jean-Georges. Let's see, has to unmute.
Yeah, I can speak again. Okay, Zoom trauma. Okay, I can go through the questions to help you, Jean-Yves. So first, yes, this is being recorded. I will share the link by the end of the week, probably maybe over the weekend. I'm just doing a little bit of cleanup and put that on YouTube. We've got a question from Jean. How do you deal with the multi-user scenario and grant that the data processed by one client will return only for this client without the risk of information leakage?
Yeah, great question. Sorry that we didn't take the question as we went through the talk. I am not certain, so if you're asking for data mechanics in particular or for Spark on Kubernetes, but I'll answer both. On data mechanics, first, we are deployed inside our customer's cloud accounts, so each customer is completely isolated. Now, obviously, within an organization, you also want to isolate, user A from leaking data to user B. And so this part is just provided by Kubernetes itself, so it also answers how you do it with Spark on Kubernetes. What happens is, first, the containers of two different apps cannot talk to each other, and Kubernetes has great security best practices to enforce it, and it's enforced. And second, you can propagate the user identity from the person launching the app. And so typically, let's say user A has an IAM role, and you can propagate it to Kubernetes and then use this IAM role to access data that maybe user B cannot access. Let me know, Jean, if I answered this, or maybe we can take the next question and go back if there is more.
So Travis is asking for the IO shuffle. Is the IO shuffle with disk only available on Spark 3, or can Spark on Kubernetes operator with Spark 2.4 have this ability as well?
IO shuffle with disks. So obviously shuffle always happens to disk. Maybe what I understand is how easy it is to mount disks, and indeed you can mount disk and make IO shuffles with disk performant on Spark 2.4. So it is available with Spark 2.4 with the operator.
So the next one from Muhammad, the infrastructure will be shared for multiple Spark apps from within an organization. How do you suggest access management for individual Spark apps with Spark and Kubernetes? It's pretty similar to the question you had before.
Correct, yeah. So yeah, the way we suggest it, so first, different ways you can specify data access. First, if everyone within your organization has the same right, you could just set an IAM role globally at the level of the Kubernetes cluster. This is pretty permissive, but it's very easy to do. You set it up once, and then all the apps running have access to the resources specified in the IAM role. If you want to have multiple groups within your organization, you have to propagate the user identity so that the person submitting the Spark app will use an IAM role that this person has access to, and so a check happens there. You can also use Kubernetes secrets, and if you use Kubernetes secrets, there are many open source tools or pet tools that help you manage them and give access to a secret to only specific users of your organization.
Okay, quick one for me. Is that working also on OpenShift?
It is working on OpenShift, so Spark Kubernetes does work on OpenShift. I personally don't have as much experience with it, but I met many people who run it, and however, the data mechanics platform right now only works on top of Kubernetes.
Okay. Question from Muhammad again. Does the data mechanics platform provide feedback to Spark application developer when code optimization is possible, others than the parameters optimization you are already doing?
Yeah, great question. And this ties back to our project to build a better Spark UI. And so today, basically, we don't provide feedback on optimizing code. The only thing that's automated are infrastructure stuff, pod sizes, and Spark configs which tie to infrastructure like memory management, number of reduced tasks, etc. And that matters a lot. But we do want to go further, and that's why we're building this free cross-platform monitoring tool. And if you look at our blog post, there's a GIF, and at the top we give high-level recommendation. And so we'd like to suggest, it looks like you have a join where maybe one key is heavily skewed, and so maybe you should use salting, or you have an app where you almost ran out of memory, you're flirting with the limit, so maybe you give more memory, or reduce the concurrency level, things like that.
Question from Xuan: Is a multi-user cluster Sorry, I'm getting old. In a multi-user cluster, how can we do? Sorry, Xuan, I'm really sorry about messing up your question. How can we do the access control such as view the Spark UI?
Yeah, this is a good question. I'm not certain on top of my mind how this works. Like if the same kind of fine-grained access control just works with accessing the Spark UI. Yeah, because the thing I showed you is kubectl port forward, and then the kubectl port forward is a right you could give to everyone. But then if you want to restrict that only the person who submits the app has this power, you may need more. But yeah, I would look at some of the main security tools around Kubernetes, because there are lots of open source tools or commercial tools that really are built for indeed restricting the level of permissions that users have on Kubernetes. So there must be a solution. I just don't know it on top of my head. Sorry.
And Milad, a bit along the same way. So are you planning for multi-tenant environment?
Multi-tenant environment, yes. So different levels of multi-tenancy. So within the data mechanics platform, it's already multi-tenant in the sense that multiple users from the same org can launch app concurrently, and they run on the same cluster. If another way you could be multi-tenant is by having a single Spark app, like multiple users submit application to the same Spark app. We actually chose not to do this. We think that it's more stable that each user gets their Spark app, and then Kubernetes dynamically allocates resources between multiple apps.
And the last question is from Srini. How do we deal with Spark streaming and Kubernetes, like processing 5 terabytes with 5 minutes micro batch intervals?
Yeah, that sounds like a great use case. So Spark streaming works on Kubernetes the same way as it does on open source. Dynamic allocation also works for Spark streaming. There's just a specific version of dynamic allocation that is built for streaming. And so you would need to set up, make sure that the app is big enough so that it can deal with 5 terabytes over 5 minutes. On top of my head, I'm not certain how many executors you need, but it should work. And 5 minutes micro batch, yeah, Spark streaming can actually schedule micro batch at a much smaller frequency, if you're much higher frequency if you're interested, even seconds or below the second level.
Okay, so I think we went through all the questions. I have one question again myself for you. Your new UI looks pretty impressive. Is that going to be open source, or is that proprietary, or is that just dedicated to the platform?
Yeah, great question. So it's going to be free and cross-platform, meaning we want that if you're using Databricks or EMR, you can use this for free. And for us, the benefit is you will learn, you will hear about data mechanics, and maybe that'll bring in more customers to our pet platform. But we don't want to only make this available to our pet customers. Now, is it open source? One part of the project will be the agent that runs within Spark, and it's important that it's open source because it gives you the safety that it doesn't do anything funky. You can audit it and you can contribute to it. The other part is really the backend that we stream the events to, and we store and we display them. And that part, we're not going to open source. It would basically, we're going to need to use some real-time event log ingestion and specialized database. So I don't think if we open sourced it, there would be a high adoption. So that's why we just want to make it easy to use and give you a URL. Maybe later on, if there's a big need and the project works really well, we could open source this. But right now, we just want to focus on getting this out as soon as possible. Hopefully, have an MVP in the fall and have really what we've shown you towards the end of the year or early next year.
That's amazing. So Piyush is sending a question. We have seen some of the job utilizing all the ephemeral storage space. In fact, some jobs have used more than 100 gig. For now, we have increased the disk space to 500 gig to resolve it. I just wanted to check if you have seen these errors before, and is that the reason why you had used disk map?
Yeah, typically when you run a large Spark jobs and with big shuffle phases, you can indeed use lots of disk space. It's worth checking in the Spark UI, which stage of your job produces these files, and indeed are these shuffle files, or are these spills, are these logs? If these are logs, then you're logging something wrong. But I just mentioned it because sometimes people forget to remove some debugging logs. And so, is this the reason why we've used disk mount? Yeah, this can be. We also use them because they're much more performant. So that's what we went through in the slides. But yeah, they can also help you address this kind of issue. And 500 gig is a lot, but pretty common for Spark workloads.
Okay, so Jean-Yves, thank you very much. Merci. This was a very interesting conversation and very great knowledge to gather. As I said, this event is recorded, so I will share the recording. And Jean-Yves and I will also be joining this Friday morning at 8 Eastern, and for a more in-depth conversation on one topic of the data mechanics platform. So you're invited. I will share the link as soon as I have actually eaten my lunch. And so with having said that, thank you very much, and we're looking forward to have more of you on our next event. Bye, guys.
Yeah. Thank you, Jean-Georges. Thank you, everyone, for attending. See you soon.